Well, hello worlds. These are CS50's office hours. So glad everyone can join us today. We hope this finds you and your family and friends all doing quite well, now especially. For those unfamiliar, office hours are an opportunity for students at Harvard and other universities to visit with professors in their offices normally to ask questions about the course they're taking, about the field they're studying, or really about life more generally. And so I'm here today, of course, with CS50's own Brian Yu.
Hi, everyone. This is Brian. Good to see everyone here today, and looking forward to hearing and answering some of your questions.
Before we dive in today, if you have questions you would like to ask, we won't be using Zoom's raise hand feature. Instead, per the slide that you should see on your screen right now, head to the URL there so that you can actually type out your question, and CS50's team behind the scenes can relay those questions to me and Brian. If you're unfamiliar with Zoom, notice that along the bottom of your screen, most likely, is a participants icon. That'll show you everyone else who's in here in the room besides me and Brian and guests. And also, there should be a chat button toward the bottom, which you're welcome to use to chat with each other, to share links. And indeed, Brian and I might occasionally paste a link there if folks would like to see something that we're talking about in real time. We won't be able to keep a close eye on the chat window for questions or, again, on the blue hands. So if you do have any questions you'd like to ask today, use the URL that you see on your screen here before we go ahead and begin. And please forgive, as always, if there's way more questions than there is time in the day, but we'll continue these tradition over the coming weeks as well. Without further ado, allow me to introduce our very special guest who was with CS50 for so many years and has gone off now into the world of academia herself, CS50's own Dr. Zamyla Chan.
Hi, everyone. I'm Zamyla. It's so nice to be with you all virtually for my very first virtual CS50 office hour. I think it's amazing that indeed it's been, I think, about 8 years that I have been with the course, even more than that. Maybe it's hinting on 9 or 10, and still there are new things every day. So I'm looking forward to chatting with you all.
Well, we're so glad to see you here, albeit virtually. Welcome back, of course, to the team. So we'll begin with just a few questions from Brian and me of Zamyla. In the meantime, if you have questions for Zamyla, for me, for Brian, about CS50 more generally, please go ahead and submit them via the URL, who was on Brian's screen a moment ago. But Zamyla, if we could, while folks fill out that form, ask a question of you. Would you like to tell the story of just how you got involved with CS50 and, in turn, CS50's walkthroughs, and for those unfamiliar, what those walkthroughs are?
Absolutely. So I took CS50 as a freshman at Harvard as part of one of the requirements for my engineering sciences major. Immediately, I had a blast during the course, made some lifelong friends through taking the course. But more importantly, it was just a really important course for me. I found it not just fun to learn computer science, but fun to learn it in the way that CS50 does teach it. And I found it really amazing how immediately student input was factored in terms of shaping the culture of the course and how the course was always improving, always innovating. And so the following year, I was able to give back in the course as my role as a CA or a course assistant. And then the following year, I was a teaching fellow, TF, as well as running my first year of the in-person walkthroughs. And in that time, walkthroughs looked a little different than what they do today. The walkthroughs were held live and they were recorded, and that recording was then later released for students who were not able to attend live. And that was me with a projector, but also with a blackboard, writing on the blackboard. And then we continued to innovate, moved to an online pre-recorded format so that the walkthroughs could be embedded within the problem set right when you launch and start the problem set. Walkthroughs have certainly had their evolution, not just during my term as walkthrough lead, but before and after me as well. The walkthroughs are ultimately intended to give people a toolbox with which to solve the problem sets, not to give the solutions themselves, but rather help people get started, help people get unstuck, and hopefully give a little bit of encouragement as we figure out the problems together. If you have more questions, I'm certainly happy to talk more about the walkthroughs in particular, but that's just a little bit of my story as walkthrough lead.
Yeah, well, we have so many photos these days of office hours on campus, which are opportunities for one-on-one help between students and the course's teaching fellows and course assistants. And it's amazing in the evenings at Harvard when we're all on campus to see just like how many laptop screens Zamyla's face is on, because students are there watching the walkthroughs. And what I've always felt personally is just so impactful, Zamyla, about what it is you've done with the walkthroughs is that far more so than me and Doug and really any of CS50's other staff that happen to appear on video, like you are literally always there in like students' moment of need. And I couldn't imagine like a better friend to have when someone's struggling with a piece set and just trying to get started or solve some bug. So thank you truly for those so many years of walkthroughs. You have been missed. And for those unfamiliar, Zamyla's undergraduate major was indeed, as she said, in engineering sciences. And even though she took CS50, Zamyla, I know you didn't exactly do your PhD or doctoral degree in computer science, but a completely different field. And I'm wondering how, if ever, you found an intersection between the worlds of CS and chemistry, which you ultimately pursued.
Absolutely. So I came into chemistry not necessarily because I wanted to study chemistry. I did, but more because of the impactful questions and the problems that I wanted to solve. And so that was all around solar energy storage, looking at how renewable energy is an amazing resource, but there are some downsides in that we need to store it all in order to fight climate change, in order to have a carbon neutral future. Now, how does that relate to computer science? Well, I think that even the name of the assignments that we complete in CS50 and at Harvard are called problem sets. They're not called homework. It's because you're setting out to solve a problem. How do I recover deleted photos from a memory card? How do I store solar energy in a better way using abundant materials to the earth? So certainly during my PhD, I did make use of the computer science that I knew, right? I did automate certain processes and both the hardware and the actual equipment that I was using, but also in terms of analyzing my data, all looking at what kind of tools are available to me. And now after graduating from graduate school, after getting my PhD, I'm now doing my postdoc at the Vector Institute for Artificial Intelligence. And this indeed has been the largest culmination of all of my background, all of my schooling thus far. My research is in building robotic laboratories that are autonomous. That means that they use artificial intelligence and machine learning algorithms that I'm helping to create to determine which experiments to conduct, and then the laboratory goes on and automates that entire process, and it's in a closed loop. So all of the results from that experiment are then fed in to the algorithm, and then the process repeats, all with the goal of finding an ideal material. So this certainly has been the ultimate culmination, the ultimate intersection between chemistry, computer science, and also my undergrad in engineering.
Well, that's amazing. I'm so glad you found your passions, intersections in these ways. And indeed, for those of you who are just starting out in computer science or have maybe taken a course or two already, for me personally, this is just one aspect of CS that I've always found just so impactful. The fact that you don't have to study computer science for computer science's sake. There are ends to it beyond the field itself. And what's just so empowering is certainly, as Zamyla's done and Brian's done in different contexts, and so many of our former students and teaching fellows and course assistants, is like taking some of the lessons learned in CS, whether it's just one class or even a whole major, and then going off into the real world and applying it truly into such a disparate range of fields as well. So Zamyla mentions problems and problem sets, which is perhaps a perfect segue to our first question from the whole group today. VJ, could we call on you to say hello and where you're from and ask your question?
Hello. Hi, I'm VJ. My question here today is, how would you go about thinking in a computer science way? Because I come from like a medical course, so the thinking there's quite different from like computer science. And then, so in a lot of medical courses, it's like you memorize this and then you apply it to real life things. But when I got into CS50, the introductory course, it was like It was quite difficult, especially on PSET2 with substitution. I had to go through each problems because I'm quite the type to like go to each part and understand, and it was quite hard for me to like see on how it would work, and like some parts would be below, some parts would be at top, then it would be called again.
I think this is a perfect question, in fact, if we made it to Zamyla. But Vijay, where are you from? Where in the world?
Philippines.
Wonderful. Glad you joined us. Zamyla, would you like to take today's first question?
I think yeah, exactly. Just as what David was talking about, the beauty of computer science is that it is applicable not just within the lens of software development, but also throughout. We see this in so many fields. And I also think that CS50 teaches us, and not to take from some of the course material, CS50 really does teach you how to think, how to approach problems. I think that even if you aren't writing a program, it is a great start to break down what you have to do into smaller, manageable pieces. Oftentimes, problems might seem insurmountable, and if you break them down into smaller steps and then even smaller steps, then you can start to see different themes appear, different patterns emerge. The same exercises that you learn as you go through all of CS50's problem sets can be applied, that same methodology, to the medical field, I'm sure. And so then just seeing those small steps and knocking them out piece by piece, you can see how they can all build together to solve a larger problem.
Yeah. Well, thank you, Vijay, for the question. Glad you joined. Can we go next to Danelle, if I'm saying your name right? Would you like to say hello and where you're from?
Hello. Hello, David. So my name is actually Jonal, and I am from Zimbabwe, but I'm currently living in Mozambique under the lockdown. So my question is that what would you suggest when pursuing a career in mobile app development? And can I couple that with web development?
Yeah, that's a really good question. I said, did you just screenshot us taking questions? Yeah, that's a really good question. Let me turn to Brian, who can perhaps speak to that one best.
Yeah, absolutely. So mobile application development is getting incredibly popular as more and more people are using mobile phones as where they're running applications and software nowadays. If you're interested in getting started, I might start with the languages that are often used in mobile application development. So if you're developing for the iPhone and Apple's devices, you might want to learn Swift, which is a programming language that has a lot of resemblances to languages like C and JavaScript that you might be familiar with from CS50. And then for Android, usually those applications are written in Java. So that might be another language that's interesting to learn too. But as you mentioned, there are definitely ways that you can connect mobile application development with web development. And there are a lot of frameworks and tools out there. One of the most popular is called React Native, which are tools that let you build a mobile application by basically building a web application using languages like HTML and CSS and JavaScript that you might be familiar with from CS50, and using those building blocks as the way that you structure and design a mobile application too. So definitely ways that you can combine those fields and different ways that you can try and build a mobile application. So I might start by just starting to learn some of those and taking a look at maybe if you want to learn one platform or the other first, some of their official documentation and resources might be helpful for that too.
Yeah, Danelle, I just pasted into the chat window the URL for React Native if you'd like to take a look there. They have some good tutorials. And it's actually an exciting time, I think, and a relieving time for mobile app development early on when there were only iPhones and Androids and at the time Microsoft phones as well, Windows phones. It was very time consuming, if not expensive in terms of time or cost to actually build mobile applications because you had to write the Android version, you had to write the iPhone version, you had to write the Windows version. And so that's like 3 times as much work as just writing one. So the types of frameworks to which Brian's alluding are wonderfully empowering because theoretically you can write one application once and it's all the more cross-platform, so to speak. And there are some constraints, things like games and other specially oriented applications might require a little better hardware support, but in general, it's a really viable path to pursue both for web and mobile. Well, thank you, Donnell, for your question. Let's go next to Jonathan. And first, a happy birthday to Jonathan. If you'd like to say hello and where you're from and your question. Welcome.
Yes. First, I'm from Los Angeles, California. And I want to thank Zamyla for helping me with the walkthrough on Recover. Definitely would not have gotten through that without that walkthrough. And my question is on code, specifically cleaner code. Some of the problem sets I'll finish and I'll look at it and all the code is just kind of all over the place, a lot of if-else statements and whatnot. And looking at it, I realize I could probably clean it up a lot better. But I don't really know what resources to kind of help me with that. And I was hoping that you guys could help me look at some resources for that.
Sure. Zamyla, do you want to speak to that, especially having worked now on code in the real world too?
First of all, happy birthday, Jonathan. And I am so happy to hear that you found Recover useful. It's a fun one, or certainly more fun once you have gotten to the other side. Yeah, clean code is certainly something that I value a lot, certainly having come to the real world, so to speak, where you're using more and more of other people's code and putting it together and working on code as a team. It is, you learn to sort of code in the way that you wish others do, to make it as readable as possible, right? Having comments explaining what you're doing, and often understanding just the pseudo. I'd say going back, I always like to go back to basics. Going back to the pseudocode to walk through the flow, see if you're making extraneous checks to minimize say like compute time and things like that. I'd say practice reading others' code, perhaps hop on GitHub and start contributing to projects. Learn what helps you read and catch on to other people's code, and that could also just help your own practice. That's something that I found was just incredibly useful, is just kind of jumping into the deep end and learning what I found useful and then implementing that myself. I'm sure that David and Brian can elaborate on this as well.
Yeah, within CS50, we actually have a protocol, which is common practice elsewhere too, at companies and in teams more generally, of doing code reviews for each other. So anytime we push updates to any of CS50's tools, whether it's Check 50 or Submit 50 or the video player or any number of other web and command line applications, we very often, especially for applications that are being used at that moment by many students, we initiate what are called pull requests on GitHub and then ask one or more colleagues like Brian or Kareem or Zamyla or the like to comment on that code. And GitHub, for instance, provides a very useful user interface for providing comment on people's code. And it is a great way to learn. And in fact, it's not without frustration sometimes, like Kareem, who you might recall from a past office hours, who's worked with us now for years on development as well as online. Like he's constantly like encouraging me, or really telling me how I can tighten code that's this big to just 1 or 2 lines. And it's actually really good because it helps to see your code through someone else's eyes. And undoubtedly, it always gets better. But I don't think that feeling ever goes away. In fact, I'm always so nervous about making some of our code open source because I'm just always so embarrassed by certain things. And I know that I've done things somewhat suboptimally. And I don't want the world to see that yet. So I think your instincts in wanting to do this are the perfect way to start to get over that too. Well, thank you to Jonathan as well. Well, could we go next to John to say hello and where you're from?
Hey, how's it going? I'm from Joburg, South Africa.
Nice to meet. What question do you have today?
So David, really loving the course. So I work with kids and code in general. And I noticed that the course has maintained a very, very particular style of learning behind it, where you have big, chunky, meaty problem sets most often. And occasionally you resort to smaller type questions like you have in the SQL section, where you ask maybe 10 or 12 very short questions or smaller problem sets. And I would love to have an insight into the way that you've thought about presenting this. Other courses often do exercises where you have to master one if statement and then nested if statements and then variables, where you've decided to just throw the whole lot together and get people to deal with these big, meaty problems. Why have you done that, and what other approaches do you think work or don't work, if you get my drift?
Yeah, I do. And thank you for the question, because we've certainly thought about this a lot over the years. And two thoughts come to mind. So with the problem sets, which in CS50 or CS50X are indeed fairly project-oriented, they're not short exercises like you might find at the end of a chapter in a textbook. It is very much by design that they are these fairly large projects, certainly week to week as the course progresses quickly. And that's in large part because I've just always found exercises that you might find in a textbook or on a practice website just so boring and so underwhelming and so undermotivating, because it's just not all that fun, for instance, to write a program that takes as input 2 integers and outputs the sum of those numbers, or something sort of rinky-dink like that. Like, it's useful syntactically for practice to sort of get the muscle memory for writing those programs, but you don't really care about the end result. And by contrast, and Jonathan alluded to this, recover, the sort of sense of gratification that you have, I hope, from actually solving a problem that's pretty significant and very real world, recovering photographs, for instance, from a camera that has been accidentally or intentionally deleted. Like, there's a motivation there, and you can see that the point of learning how to program isn't to learn if conditions and loops and functions and parentheses and curly braces and all of those sort of lower level implementation details, but to use it to solve problems. And so hopefully CS50's problem sets really do empower students to see programming as a tool, but really just a means to an end, not something to study for programming's sake alone. And then on the other side of CS50, of course, we have not only on campus, but also as best we can online, various community traditions. Just a couple months ago was CS50X Puzzle Day around the world, which is based on an event we do on campus. And some of you might know about CS50's Fair, which is something we do on campus at the end of every semester. And we've also held it in other cities with other students as well. It's an opportunity at the end of the semester for students to showcase their works, their final projects. So, and this was motivated, honestly, by my first year teaching CS50 back in 2007. We had a few hundred students in the class, and we had many teaching fellows who led sections for those students, which are small, more intimate classes or recitations, so to speak. And at the end of the semester, we did what a lot of classes did, which was we had every student in a section, and there were 10 to 20 students in a section, present their final project to the class. And so they would walk up to the front of the room, they'd bring a computer, they'd project onto the wall their project, maybe it's a web app or something else, and then their classmates and the teaching fellow in the room would watch and would listen. And honestly, it was just so incredibly boring and underwhelming. And you're doing 10 to 20 of these in a room, and dozens of rooms because we had hundreds of students. And I, as the instructor, couldn't even physically visit with all of the students or see many of the projects because they were all happening in parallel. And long story short, that approach to projects was just so ordinary, and no one really wanted to be there, and that seemed like such a missed opportunity. So the CS50 Fair, which we debuted in 2008, was meant to be a much grander scale event to which we invite not only our own students, but other classmates of theirs, students and faculty and staff and tourists even in Harvard Square, to come see what it is students accomplished and turn it really into a collective shared experience that people want to go to, as opposed to some obligatory or ordinary end of semester event. So I would say that sort of approach to thinking differently about how things have been done traditionally is what motivates a lot of what we do in CS50 on campus and off. Well, thank you, John, for that question. Allow us to turn next to Nina, if you'd like to say hello and where you are from.
Thank you so much for having me here. It's great to be here. My question is, I'm really interested in logistics, like because I do events and I used to work in production. So I realized that whatever you do, you always have logistics. So I'm interested in coming up with a program or maybe use a mobile app in the future and move things like from person to person. Like, how do you track like a spoon? If I pass the spoon to another person and and then that person moves the spoon to another person. How do I track that? It's like data, but it's more of the tracking and the ability of people to find that spoon immediately and who has it.
Yeah, that's a really interesting real world challenge. Brian, do you want to offer your thoughts on this one?
Yeah, sure. So I think my advice more generally, anytime you're trying to build a big application from scratch, is to first start by thinking about the big decisions you might need to make even before you start writing any code. So these are things like, is it going to be a web application or a mobile application? Is there going to be a database that your application needs? And if so, like what data are you storing? What tables might you need? And what columns might those tables have, for example? And then like, what are the specific things your application needs to do? And once you have a more formal sense of the answers to those sorts of big questions, then I'd say you can start writing the application. And generally, I suggest building incrementally, building one feature at a time rather than trying to write all the code for the entire application all at once. Because I can imagine for something like logistics, there are probably lots of moving pieces, lots of different features that go into that application. So starting with just the maybe first most important feature and then adding on piece by piece from there can just be helpful to break up a big problem into smaller problems that feel a little more manageable, because building a whole app is a really big endeavor, but building one feature is something you could probably more tangibly accomplish. And once you do that, then you can do the next feature, testing your code along the way, and hopefully at the end of it, you'll end up having an application that does what you want it to do.
Nice. Well, thank you, Nina, for that question. Can we go next to Isabella, if you'd like to say hello and where you're from?
Hello, I'm from Brazil, and my question is, like, before quarantine, I was studying programming at school, and as someone asked lately, we were studying we had some questions that were like unrealistic, and sometimes when we like see programs like ready at school or even daily, I was thinking, what are the greatest challenges in computer science today? Because we're always so used to see everything ready, like everything exists. So I was curious.
Wow, that's a big one. The greatest challenge in computer science. Let's go first to Zamyla for the world's biggest question.
The world's biggest question in computer science? That's
challenge.
A hard one.
Indeed.
The biggest challenge in computer science. Wow. Isabella, it's a great question, and I can't say that I have the answer. I think that there are so many. I mean, for me, I'm most focused in artificial intelligence field. So there is a lot of huge questions there, but then I'm sure there are such. I can't say whether there might be someone else right in the like mobile app like software field who might say, oh well, no, this is the biggest challenge. I mean, David and Isabella, this is a hard ball here. I can't say that I can answer on behalf of all computer scientists, but I would say, like, I mean, there's so many cool things happening in academia right now. If you look at the like just research papers that are going out about quantum computing, and which is what much of my work does, much of my colleagues do. Or if you look into like AI, like P versus P problems, that's certainly where I am more biased. I'm curious to know, David, what you think.
It's funny you just mentioned that, because I just pasted a link into the chat for what is called the P equals NP problem, which is actually perhaps the most fundamental question in computer science that, in a nutshell, asks the questions, can certain algorithms that currently take a lot of time to finish, can those problems be solved fundamentally faster? And if they can, that has wide-ranging implications for what is possible in terms of security and in terms of cryptography and the like. So read up on that if you haven't already. That's a topic that you would typically find in a higher level course than, say, something like CS50. I think the response that comes to my mind with regard to challenges is to consider that computer science really at the end of the day is about information and how you can manipulate it and how you can mine it for answers and really use information to solve problems. And there's just so many applications of that certainly in the world today with an increasing amount of information, whether it's in the business world, whether it's in the governmental world, whether it's in the consumer world. And so computer science really has an opportunity to solve problems using that information, connecting people, much like social networks have begun to do, not necessarily for the silly sharing of memes and the like, but to keep people in touch and more intimately connected. And indeed, if you consider what's been happening in recent months around the world, the fact that we're able even to have this conversation and stay in touch is really testament, I think, to some of the kinds of problems that you can begin to tackle with computer science. So thank you, Isabella, and I think we'll both probably continue to think on that one as well. Well, let us go next, if we may, to Jonathan. If you'd like to say hello and where you are from.
Hi everyone, Jonathan here from Singapore. Thanks for having me. So my question is to either David, Brian, or Zamyla. Could you share an example of how you've used any coding language to solve a community, economic, or government issue?
Oh, that's a good one. Zamyla, can we actually come back to you, especially since contact tracing comes to mind and some of your current work too?
Absolutely. That's another great question. So I suppose I'll tell a little bit of a story. First, when the coronavirus COVID-19 pandemic started to hit, I was approached by a couple of people within like Canadian government asking, how can you adapt some of your autonomous laboratories? How can you adapt some of the algorithms that you work on to help fighting COVID? And certainly some of our research then turned to how can we adapt some of these labs, change our algorithms slightly to discover a cure or better soaps, things like that. But through doing research into COVID-19, because we were all like material scientists and chemists, the largest solution that we saw was actually that technology could help with contact tracing. And so I'm in Canada, I'm Canadian, and so focusing on the Canadian perspective, I actually founded a nonprofit called MyTrace. And so we spoke to government officials, we spoke to public health and doctors and people doing contact tracing, and we spoke to lawyers and people interested in cybersecurity. So all different fields were really interested in talking about contact tracing, which is when someone has an infectious disease, when you get this infectious disease, then someone from public health wants to know where you might have been so that they can figure out who you might have come into contact with. And so this process right now in Canada and in many places around the world is conducted manually with people just on the phone asking you where you've been. And you can imagine if I were to ask any of you where you've been within the past 14 or 28 days, some people might be fully in self-quarantine and could answer that. But even when it comes down to exactly what time you might have gone to the grocery store, or for someone who's an essential worker and does have to travel, perhaps they have to go on public transit. And so I'm going a little bit more into contact tracing now, and it's certainly a topic that most recently I've become really passionate about, but that's somewhere where technology could really step in. But technology, the most advanced solution is not necessarily the best one, because there are other things that you have to consider, such as the existing structure that public health needs. We're in the middle of a pandemic, so it's kind of hard for public health systems to completely change the system that they have for a fully digital one. And there are things that need to be considered there, as well as privacy concerns and security. So it's a really fantastic question. That's one example of where technology could absolutely help and has the potential to help in a situation such as the crisis we are today. And there's so many other examples, but that's something that personally I have become really passionate about for the past couple of months. So thank you very much for the question.
Yeah, thank you, Jonathan. Well, next, could we go to Mithilesh? if you'd like to say hello and where you're from. And I'm hoping I pronounced your name right too.
So I have gone through past CS 75 lectures taught by David, and I would like to know where does it stand in comparison to other present-day CS50 courses.
Yeah, really good question. For those unfamiliar, years ago I used to teach a course at Harvard's Extension School or continuing education program called Computer Science E75. I just pasted the URL in the chat window of the open courseware for that course. I haven't taught it in many years because it's actually evolved into a different course at Harvard Extension School called Computer Science E33A, which is perfect since a certain someone here with us today teaches that course now. So allow me to have Brian elaborate.
Yeah, so David's CS75 course really acted as a predecessor for CSI E33A, which you might know better as CS50's web programming with Python and JavaScript, which is now available on edX. And it basically covers a lot of the similar ideas of building dynamic web applications. Now, there are some differences because over the course of the last 8 years or so, trends in web programming have changed. Back then, PHP was a little bit more popular as a language to build web applications in. Now Python is a little more popular, so we're using Python as the language that we use in the class. And in E33A, we also introduced some more modern web programming frameworks. So frameworks like Django, which is a Python framework for web programming, in addition to React, which is a JavaScript library designed to make interactive user interfaces. Those came about a little bit more recently, but we talk about them because they are quite popular now in the web programming world. But aside from that, a lot of the topics are very similar because a lot of topics in web programming stay pretty consistent. You want to think about web programs as they scale and the issues of scale that come about. You still want to think about security and making sure that the web applications you build aren't going to be vulnerable to malicious attacks, for example. You still want to think about how to organize a web application in a logical way, separating your data from the view and what the user sees from the code that controls it all and ties them all together. So a lot of the key ideas are very similar between those classes. E33A just happens to use some more frameworks and languages that are more popular for web programming now.
Indeed. I'll go ahead and paste into the chat window 2 URLs. The first is the OpenCourseWare version of this course, Computer Science E33A, otherwise known, as Brian notes, as CS50's web class, and also on edX as well. So if you'd like to take a look at any of those materials, feel free to take a peek there too. How about next, let's go to Ruth, if you'd like to say hello and where you are from.
Hello, I'm from the United States. So my question is, I've wanted to learn Lua for like a while, but like I've like been worried it would be like a little bit like too hard since it's like a high level coding, and since I'm only in the CS50 Intro to Computer Science. So do you suggest I start looking into it, or should I first get past the CS50 Intro to Computer Science?
Yeah, that's a really good question. I can perhaps answer that, if only because I've chatted so much with Colton Ogden, who teaches CS50's game class, which uses Lua throughout most of the semester. I think, honestly, you should never not learn something because you think you're not ready. There's certainly no downside in simply trying. And then if you decide, wow, I really don't know what's going on, then maybe take a step back and fill in some of the gaps in your knowledge and learn some more of the fundamentals first. In general, I would say our advice is for students to finish taking CS50 or CS50X, if only because it is an introduction not only to computer science, but to procedural programming more generally. And as you know, probably already, we introduced C and Python and JavaScript and SQL, all of which are representative of a certain type of language, very similar in spirit to Lua. But Lua is a language that indeed is a little higher level, and it has other features that some of those languages don't have. But we use Lua in Colton's games class because it's a wonderfully accessible language for implementing two-dimensional games. And by accessible, I mean relatively easy to understand. In fact, of all of the languages we use across CS50's courses, I actually am a big fan of the design and simplicity of Lua. Now, it does have certain features, like object orientation, that we don't introduce in CS50, so there's still going to be a bit of a learning curve. But I think my best advice would be to never hesitate, honestly, to dive into something that seems of interest to you, especially if you feel you need a little bit of a break from CS50 or some other class. You'll know if it's maybe too soon for you. Don't necessarily rely on others for that advice. There should be nothing stopping you otherwise. Well, thank you for that question, Ruth. Let's go next to Nicholas, if you'd like to say hello and where you're from.
Yeah, thank you for having me. So my question is, in a career of programming or, going through CS50, what kind of other skills, maybe more softer skills besides maybe logical thinking or are useful in a career of programming? My examples that I asked were, communication, obviously working within a team, or skills that involve creativity. And I think, at least for me, like knowing what is useful is sort of motivational in completing the course when, we really are having tough times, tackling problems and having existential dread of if we could ever get a career in programming. So what else could we develop, through our other schoolings or other skills that we can develop that will help in a career in software development or something like that?
Yeah, that's a really good question. Zamyla, so your world isn't software development per se, but you certainly use programming as a tool with which to solve other problems. Do you want to speak perhaps to some of the characteristics you've seen work well or not well when collaborating with folks, technical and non-technical?
Absolutely. I think that in terms of soft skills, communication is key. I mean, even amongst you see that one of the biggest tools that helps programmers interpret other code that others have written is also is often in the comments themselves, not necessarily the programming the language that they've programmed in. I would say that just being able to communicate in layman's terms to an audience, both technical and non-technical alike, and being able to convey your message is definitely very important, but also being able to receive feedback and be able to work on both giving and receiving constructive criticism as you work in a team. Other soft skills that I would say that I think that the lockdown has brought to light for me especially is just self-organizational skills. And so your own internal project management. If you find certain productivity hacks. I'm actually standing right now. I'm at my standing desk. Small things like that, and just understanding how you yourself work best will help you find and identify a working environment that would work best for you as well. But ultimately, I'd say the number one skill would be communication, would be putting slides together, would be just explaining a complicated problem and breaking it down into terms that everyone can understand.
Yeah, well, very well said. I agree. How about let's go next. Thank you, Nicholas, for that question. To Makarand, if I'm pronouncing it right, if you'd like to say hello and where you're from.
Hello, I'm from India.
Nice to meet.
So my question is, in CS50, the problem sets are from various fields like cryptography, finance. So how do you decide which problem sets to include and which to not?
How do we decide which problems to include and not include in a problem set? Yeah, that's a good question. And I dare say Brian has thought an incredible amount of this over the past year because he was instrumental in bringing new problem sets to CS50X this year. Brian, do you want to field that?
Yeah, sure. So I've written quite a few of the problems that are in CS50X. I've also written quite a few problems that didn't end up making it into CS50X for one reason or another. And in general, we typically start by thinking about the topic that we want a problem set to be about. Like, I'd like a problem set that has something to do with music or something to do with elections or something to do with images, for example, because that way we can help to connect computer science to other fields. And then after that, what I usually start to think about is after I have a topic in mind is I ask a question like, all right, how do I take this week's topics that are being taught in CS50 and apply them somehow in a useful way to whatever the other topic that I'm interested in happens to be. So for example, arrays lend themselves pretty well to like arrays of colors if you're trying to put together an image, because an image is just a sequence of colors. Or sorting algorithms offer a pretty nice way of putting candidates in an election in order of how popular they are, for example. So you can come up with ways that the topics from the class apply to these domains, and I'll draft a problem around that. And then after that, it usually goes through a testing process. I'll send the problem out to some staff for the course and have them try it and see if they think it's too easy or too hard or too boring. And based on that, sometimes we decide, the problem probably not a good fit for the class. And other times we'll go through a revision process and it ultimately turns into the problems that are part of the class.
Yeah, I know CS50's problem sets very often take quite a bit of time, recover, for instance, among them. And I don't know if it's any reassurance, but I can say that we, CS50's staff, probably spend more time writing the problem sets and testing the problem sets and improving the problem sets than students do working on them. Perhaps that's not any consolation in the moment when you're faced with some bug, but indeed it's a very methodical process, and Brian did such an amazing job this year at breathing fresh life into a lot of the course's P sets. So our thanks. Let's go next to Akash, if we could, if you'd like to say hello and where you're from.
Hi, David.
Hello.
I'm from India. So I wanted to ask about teaching, basically. So when you're learning something new, right? For example, when Python was introduced. So how do you know that you are comfortable enough to teach it, And also the second part of the question was, how do you keep the audience engaged in any lecture that you give?
Yeah, let me, I see Zamyla smiling too, so I'm curious to hear her thoughts. I can respond directly to your first question, though, with a simple answer. I don't know if I ever know that I'm comfortable enough to teach something. In fact, I'd like to think, though I'm perhaps rationalizing reality a bit, that I do a better job when I am a little bit uncomfortable because it motivates me to try to learn the material all the more. So case in point, a few years ago, we switched from using PHP in CS50 to using Python for the web programming portion of the course. And at the time, we decided, we had actually had this discussion probably for 2 or 3 years internally with CS50's teaching fellows and myself, and the time felt right this particular year to make the switch. The catch was I did not actually know Python yet at the time, and I think we must have decided in April or maybe even in the summer, June or so. And then, oh my God, October was upon us, and I still hadn't learned Python, but it was on the syllabus, and we were going to teach Python no matter what. And it was perhaps among the more risky approaches to teaching some material, but it was such amazing motivation, that discomfort with having to learn something new, that it actually helped me learn the material much better than I think if I were simply taking a course on Python. Because when I was reading up on tutorials and I was doing practice problems and following along with other people's teaching materials, I found myself always so curious to go down one rabbit hole or another, so to speak. So if I didn't understand something, because I'm supposed to be the teacher the next day, it is not acceptable for me to not understand something and realize I don't understand it, but not figure out the answer to it. And really, it was risk aversion. I certainly didn't want to feel caught off guard by a very good question by a student in class and not have an answer if I had had an opportunity to at least figure that out in advance. That's not to say you should know everything going in. I'm sure students asked questions that I didn't know the answer, but it was a responsibility I felt in learning the material that I should at least have an answer to any question I myself have as a student when learning the material. So this is to say, I think a little discomfort's a good thing, and if you're already thinking that you want to teach some subject irrespective of your discomfort, it's probably time, because you'll only get better at it along the way. And Zamyla, if we can go to what motivated your smile a moment ago, how you think about this?
Yeah, I think that it is so true what you say about when you talk about discomfort. It's certainly, actually, I would identify and I would agree with that as well. Some of my most favorite learning moments and some of my also best moments as a teacher are often the same moment of going through a little bit of that discomfort, being on and working through that. There have been many questions that students have asked that challenged me to understand the material more deeply. So I did know the answer. I could help them, but thinking about that question in the way that it was posed helped me understand through my explanation to that student, helped me understand the concept even better than before. I think that for myself, I look at my philosophy for life is that I am always a learner, and that you don't necessarily start teaching only once you've reached the other side. It's the act of teaching itself is also a learning process. Now, another important thing to do, though, is to stay honest throughout this process. If you do, I think there's a certain responsibility as a teacher. You don't want to disseminate incorrect information, right? So if you truly don't know something, then I think that a really valuable process is, rather than maybe make a guess, is actually work through it together. Say, you know what, I don't actually know this yet, but let's work through this together. Let's look up the right resources and find the answer together. So I would say the honesty, and also being able to work through that discomfort is really important as part of being a student as well as being a teacher.
Well, thank you for that question as well. And I should state for the record, I do know Python now. So I figured that one out some time ago. And in fact, it's probably the language I now use most. So thankfully, I got my footing. Well, let's go next, if we could, to Nisa. If you'd like to say hello and where you're from. Nisa.
All right. So yeah, I've been learning programming for a year now. And I have been doing the CS50X few months ago. And now I'm doing CS50 web programming with Python and JavaScript. I'm working on my final project. And yeah, it gets me excited. And my question is, to be a full stack developer, JavaScript developer, what should I do next? Do I have a next course from CS50? Like I'm seeing React Native and stuff like that. Yeah, I'm not sure yet. So maybe some suggestion for me. Thank you.
Sure. Let me turn to your own instructor, Brian Yu.
Yeah, so best of luck on your final project. Glad to hear that you're having a good time with the class. So in general, when we think about full stack web development, what that means is a combination of two things. It means writing code on the back end, like the web server, and then writing code on the front end, what the user sees inside of their web browser, for example. And so if you're interested in becoming a full stack developer, you'll want to spend time doing both of those things. And for JavaScript in particular, one backend framework that's quite popular is one called Node.js. Just happens to be very popular nowadays for using JavaScript on the back end. But in general, my best advice really is that once you have the foundation from taking CS50, from doing some web programming projects, is to build more projects of your own after finishing your final project. Find something that's of interest to you and start writing a web application around it. And in the process of creating your own web application, you'll run into things that you don't know how to do, that you weren't explicitly taught how to do. And that'll be an opportunity for you to do a little bit of reading, do a little bit of research to figure out how to solve those sorts of problems. And in the process of doing so, you'll get better as a web programmer and learning how to identify these problems, solve them, look for commonalities between different problems that you've already solved. So getting hands-on practice, I think, is really one of the best things that you can do to keep on improving.
Nice. Well, thank you for that question, Nisa. Looking forward to seeing the video of your final project soon as well. Well, I think we have time for just one more question. And after this, what we've been doing as a new tradition is taking a group photo of sorts, whereby we'll take a few seconds to have everyone smile and wave if you would like to participate. And we'll take a whole bunch of screenshots and then stitch them together and post them online later today or tomorrow so that all can remember this time together with Zamyla. But for our final question here, and please again forgive if we didn't quite get to your question as well, Mateus, could we come to you for a hello and where you're from in the world?
Hello everyone, I'm from Brazil. And my question is about how can computer science impact different majors? Because in my example, I come from humanities. I'm studying design and I found in, for example, social media, sentiment analysis and this kind of things. And just in my master's, I found that it's really important and can be really helpful. And my question is, how can computer science be more than a major and influence other fields? So if you get what I mean.
I do, and I bet Zamyla does as well. Zamyla, would you like to take this one?
Certainly. Bom dia. Thank you for your question. I love this question because myself going in studying engineering sciences at Harvard and then later to go on to chemistry, but maintaining my connection and my education in computer science at the same time in parallel was really important. And we're seeing more and more that all fields are, well, many fields are starting to incorporate computer science. I was in a meeting with mostly chemistry professors and material science professors, chemical engineering at the University of Toronto, and all of them were saying, look, chemists nowadays, the new generation, they all have to be coders because there is just so much that chemistry is just moving so fast now in terms of incorporating calculations and computational chemistry, but also in just running equipment, things like that. You see the field of law having like natural language processing to help speed up certain processes. You have a lot of problems and just different processes in so many different fields that are benefiting from having computer science or having code help speed up and also many times enhance the process, right? It's not always just about doing something faster, but sometimes also about doing something more thoroughly and in a different way, being able to recognize certain patterns. Pattern recognition isn't something that just exists within computer science. It's something that exists, I think, throughout all fields. And I think what's really interesting is to have people not just stay in computer science, but I want more chemists, more English majors, more people in medicine all over who understand, who may be proficient in whatever language it might be. I don't care about that as much as I do about the general methodology about approaching problems and being aware of what is possible, right? So saying, oh, I know that it'd be possible to automate this. I'm sure that I can pull from this GitHub and this source and maybe, talk to someone else to help build this code with me, I think is really inspiring despite what field you're in. So yeah, I think that you're thinking in exactly the right direction, and that's certainly how I like to think as well.
Well, thank you, Mateus, for that question, for Zamyla for that answer, and all of today's answers. And Brian, would you like to give folks a closing remark as to what's in store for folks next week, if you would like to join us in lieu of office hours?
Yeah, absolutely. First, thanks so much, Zamyla, for joining. And next week, what we'll be doing in lieu of office hours will be a brief look at artificial intelligence, looking at what it is, what it's all about. So if you're interested, I'd encourage you to tune in then, and we'll see you next week.
This was CS50. We hope to see you all soon.